For problem number 3, we're going to do a really close read, and then we're also going to again draw a picture. So a rectangular picture measures 6 by 8 inches. Simon wants to build a wooden frame for the picture so that the frame picture takes up a maximum area of 100 square inches on the wall. The pieces of wood he uses to build the frame are all the same width, but we don't know what that is. Write an equation or inequality that could be used to determine the maximum width of the piece of wood for the frame Simon could create. Okay, well, let's start by drawing a picture. So here's my picture. It's a picture of me. Okay, kind of great. I look fantastic. So here's my picture, and I have measurement 6 by 8. Well, I want to put a frame around this. And the frame is going to have the same width all around. So whatever this value is here, let's call it width, W, is also going to be the same here and here and here. It's all going to be the same. So what that means is the top is 6, but then on either side I have W on this side that I'm adding this much, and W on this side that I'm adding. So the center part is 6, but then I have 2W. So 6 plus 2W. And then the height of the frame is 8, but I also have this piece here that's a width of W and a width of W at the bottom. So my height is going to be 8 plus 2W. And this is a maximum of 100 square inches. So now we need to write an equation. We know that the area of a rectangle is length times width. So let's say that our maximum height or our maximum area is 100. Technically, we could say less than or equal to here, and that would be fine. If that's too intimidating for you, you can just say it's equal to, and then in your language, explain that that's the maximum, the maximum when you do your explanations. So if this is 100, okay, is less than or equal to, and now I'm going to say my length times my width. It doesn't matter which dimension you use, as long as you put one and then the other. So I'm going to say 6 plus 2W times 8 plus 2W. Well, now I need to simplify this because it tells me that I need to identify the maximum width of the piece of wood for the frame. So I need to solve for W. So I'm going to do this by simplifying. Well, I'm going to just do FOIL to distribute, or I can use the box method. So I'm going to do a box. So I'm going to say 6 plus 2W and 8 plus 2W. So 6 times 8 is 48. 8 times 2W is 16W. 2W times 6 is 12W. 2w times 2w is 4w squared. So I'll combine like terms. And we'll say 100 is less than or equal to, and now I'm going to put this in standard form. So I'm going to start with 4w squared first. Let me add my equal sign here. Plus 16 plus 12 is 28w. Plus 48. So now, if I want to be able to solve this, I need to subtract 100 on both sides. So what that will do is 48 minus 100 is negative 52. So that's going to change my equation to minus 52. And now this is set equal to 0. So now I need to begin to solve. I can do this a couple ways. I can try factoring if I wanted to. So let's see here. 4 is divisible by 4, 28 is divisible by 4, and 52 is divisible by 4. So I can say, I can divide everything by 4 and at least get rid of that yucky leading coefficient. So I'm going to kind of step aside now and say, we have 0 is less than or equal to w squared plus 7w minus 13. Let me add my little write-ins here, or equal to and squared. So now I need factors of negative 13 that add up to 7. Negative 13 is prime, or 13 is prime. So there isn't any factors other than negative 1 and 13, or negative 13 and 1, and neither one of those add up to 7. So I'm stuck with factoring. So now let's try our quadratic formula. So we have x equals negative b, so that's going to be negative 7 plus or minus the square root of 7 squared minus 4 times 1, there's a leading coefficient here of 1, times c, which is negative 13. Let's extend this, all over 2a, so that's 2 times 1. Okay, well, we have, this is going to equal negative 7 plus or minus, and now let's start to simplify under the radicand. Let's simplify the discriminant. So we have 49 plus, because it's a negative 4 times a negative 13, positive 52. All over 2. And at any point, you could just put this into your calculator and evaluate. So now I'm going to enter this into my calculator. So I have negative 7, and I can't enter plus or minus into my calculator. I have to do these individually. So I'm going to say negative 7 plus the square root of 49 plus 52. And then I can isolate this whole thing and say we're dividing all of this by 2. And I get an answer of 1.52. So my width could be 1.52. But now I have to go back and say, okay, but it's also or minus. So let me do the subtraction sign instead. And I get a negative number, negative 8.5. But when we're dealing with real world situations, we have to consider that there's going to be options that we have to reject. If we're talking about the width of something or the length of something, then we, just like time, we have to reject the negative. So this is not a viable answer, so we reject this as a solution. So our final answer is going to be that the width has to be at most 1.5 inches because it asked us to round to the nearest tenth.